Hi, everyone. Thanks for joining us. I'm Serena, the Algorithmic Inclusion Stream owner at AISC. So AISC is a global community of machine learning enthusiasts and practitioners founded in Toronto, Canada. So we're currently working on creating a repository of YouTube videos that showcase authors talking about their research. Because with all the machine learning research that comes out every day, it's hard to figure out what to pay attention to. So our hope at AISC is to make this a bit easier by highlighting the work that we feel is important. And we also host social events where you can get a chance to network with fellow community members, and we host workshops that can teach you how to translate machine learning theory into code and real-world applications. So today we're joined here by Melvin Johnson, a senior software engineer at Google Research. And I'm really excited to have Melvin here with us today for our first algorithmic inclusion stream. So we interact with machine learning application-based or machine learning-based systems all the time in our daily lives, whether that's through being recommended products when you're shopping online, applying for credit cards from a bank, to using Google Translate to help you learn a new language, remember something you may have forgotten in a language, or you may use Google Translate to try to read some text in some language that you don't know at all. But machine learning systems, they can be biased due to societal and systemic biases present in their training data. And you may be familiar with the classical word-to-vec case. So this is the work of McDonnell et al., also from Google, where combining the word embeddings of king minus man plus woman equals queen. And word embeddings, they certainly can be powerful, but they also highlight relationships such as, mentioned, king is to man as woman is to queen, but also man is to doctor as woman is to nurse. And this is because of society, and as a result, our training data is biased. So the algorithmic inclusion stream, it focuses on research that works to highlight, or sorry, not to highlight, but to mitigate these biases. And today we'll be hearing about Melvin's work on creating a scalable approach to reducing gender bias in Google Translate. So in this work, Melvin and the team at Google Research, they tackle the problem of creating translations in Google Translate that are not biased by gender. So for example, a translation of "they are a doctor" in some gender-neutral source language, that should yield both "she is a doctor" and also "he is a doctor" in English, for example. And they do this by taking a post-editing approach where the initial translation of "they are a doctor" is then translated into either gendered version, and then through post-editing this gendered translation, both versions will then be displayed to the user. And as you'll learn, this approach of post-editing is scalable, as it only requires writing a gender-to-gender sentence-level rewriter. So it's very interesting work and certainly makes an impact in mitigating these societal biases, and I'm really excited to hear from Melvin and discuss his work further. So we're trying out a slightly different format for the event tonight. So first, Melvin's going to be presenting a 15-minute overview of his work, 15 to 20 minutes or so, and that will be uninterrupted. And then we will discuss his work for a half hour or so, and I've prepared some discussion points. And to the audience, please feel free to drop any discussion points you might have into the chat, either over YouTube, LinkedIn, Facebook, or even Slack if you want. And I'll make sure to ask those questions during the discussion portion of the talk tonight. So Melvin, yeah, thanks so much for being here, first of all. Really appreciate it. And yeah, if you're ready to go, please go ahead.
Okay, thanks a lot, Serena. I think that was a really good introduction. So hi, everyone. My name is Melvin. I work in Google Research, specifically on the Google Translate team. I've been at Google for about 5 years now. And all of the 5 years I've been working on Google Translate on the research side of Google Translate. So today, I'm going to talk about the work that we've been doing on how do we handle gender bias in Google Translate. So let's get started. So we all know there are lots of concerns with AI and machine learning, especially when it comes to bias and different kinds of biases, right? We've seen the articles in the press about bots being racist, about algorithms being racist, voice recognition being sexist. Of course, translation is also very much included in these examples, right? So here you have an article from Fast Company from 2015, which talks about Google Translate's gender bias problem and also some of the other translation engines like Bing and Sistran, for instance, right? And this is specifically the problem that Serena mentioned earlier, is because we learn from data that's out there, we make associations like doctors are men and teachers are women, and things like that. And here is an example of Google Translate, actually. So specifically, the first example, if you look at it, it's trying to translate from Turkish to English. So Turkish is actually a gender-neutral language. And what that means is they don't have a pronoun for he and she. They actually have the same pronoun that could either mean he or she. So the pronoun O here actually refers to either he, she, or it, and it depends on the context, right? So when someone's typing in Ober Hemsir, it could either mean he is a nurse or she is the nurse, but we pick the translation she is a nurse. And when someone's typing in Ober Doktor, it could either mean he or she is a doctor, but we pick he is a doctor, right? So we're making that association that doctors are masculine and nurses are feminine. If you look at the example at the bottom, you're translating from English to Spanish. So now we know that in English, these words like doctor and secretary, they're not gendered, right? Whereas when you go into Spanish, these words are actually gendered. So when you say, I talk to my doctor, and you translate it into Spanish, Google Translate actually picks the male doctor. And when you say, I talk to my secretary, and you translate it into Spanish, Google Translate picks the female secretary, right? Again, we're making an explicit association here. So how do we address this problem, right? So when it comes to gender, what's the right gender bias in translation? What's the right thing to do? So if we have some ambiguous gender in the source sentence, that must be resolved for linguistic reasons, right? Because it's ambiguous in the language that we're trying to translate from. What should we do, right? We have a few options. Let the training data vote. This is the current behavior, and it's not satisfactory because we know that our training data is biased. And for instance, when we did an analysis on our training data, we found that the training data has 3 times more masculine data than feminine data. And also, we know that the training data itself tends to make these societal assumptions about certain occupations being related to certain genders, for instance, right? Can we adopt gender neutral variants? So we've thought about this option, and one of the downsides of doing this is many of our users actually consume Google Translate who don't fully understand English, for instance, or don't have a perfect understanding of the language that they're translating into. So they might be easily confused when we're saying they are a doctor or they went to the market. So we need to figure out what's the right user experience to surface this. The other option is to flip a coin. This is much harder than it sounds, because even if you flip a coin and you randomly pick between a masculine and a feminine translation each time, to certain users at a certain point in time, it might still come off as biased. For instance, if I am looking at the translation and we decided to flip a coin and you pick the feminine one, and then we flip a coin again and we pick the masculine one, you're still not removing the fact that you're biased. So I think the right thing to do is, where possible, we have to change the task. So instead of the task being a single sentence input to a single sentence output, we want to offer multiple answers, if possible with explanations. We want to give users more control by letting them either choose the options they want or tell us that they don't like the option that they're seeing. And this is what we did. So in December of 2018, we actually launched this feature where when we detect a gender ambiguous source sentence, we actually provide both the masculine and a feminine translation, instead of picking one translation that might be biased. So we wrote up a blog post about our approach, how we went about it, and what we launched was actually for single words. What we did was we could look up a dictionary of masculine and feminine translations, and we would show both the masculine and feminine. For example, if you typed in nurse and you wanted to translate it into Spanish, you can get both the masculine and the feminine words for nurse, right? So this is easy because you just have to ingest the dictionary, make sure you have both the masculine and the feminine variants, and then surface them. But how do we deal with sentence level support for this kind of phenomena, right? So first, for example, in this Turkish to English example, you have to detect that Ober doctor is ambiguous. Then you have to have a way of generating both the masculine and the feminine translation. So this was much more involved. And the way we did it was actually by using a 3-step approach. So what we did initially was we had a classifier that tries to detect when the source sentence is ambiguous. So once we know that the source sentence is ambiguous, we try to generate both masculine and feminine translations for that ambiguous source sentence. And for generating translations, we use these models that are called sequence-to-sequence models. They are similar to these very popular BERT models that you've heard of. It's a transformer encoder or an RNN or an LSTM encoder, and they have a decoder. So the encoder encodes some text, and the decoder produces some translation, right? So we need to change this sequence-to-sequence model to be able to produce both the masculine and a feminine translation. And then finally, we want to check actually that these translations are valid. And what I mean by that is for a sentence like "Oh, dear doctor," you generate a masculine translation that's "he is a doctor," and you generate a feminine translation that's "she is a doctor." Now you want to check that these two translations are the same except for gender. For instance, we don't want to show pairs where one is saying he is a doctor and she is not a doctor. These are not equal and they're not parallel. So we do this final check where we try to make sure that they're aligned, and the only thing that changes between them is gender. And since we launched in December 2018, we've actually expanded this feature to one of our biggest languages. So Spanish going into English is one of our highest traffic languages, one of the most popular directions. And so now when you type in English, "my friend is a doctor," we show you both the masculine and the feminine variants of doctor. Before, we would just pick the masculine variant of doctor. And we did the same approach here. So we had to build a classifier in English to detect when the English was ambiguous. We changed the machine translation system to produce both masculine and feminine variants. And we had this validation step. So while we were doing this, it took us a while to move from doing Turkish to English to doing English to Spanish, for instance. We realized that there were a bunch of issues with this approach. One, there were quality issues. So what we did was we were generating these masculine and feminine translations from the model independently. So what that means is we would first generate a masculine translation, and then independent of the masculine translation, we would in parallel generate a feminine translation. And what happened most often was the model produced translations that were not exactly parallel. So sometimes these mistakes are pretty innocent. So it will say something like, "he is smart and she is beautiful." And this is not exactly parallel, but maybe it's okay if we show it to users. But we decided not to show these because we wanted to be pretty conservative with what kinds of masculine and feminine translations that we showed, right? So what happened then was, because of the strict criteria that we had, we could only have a recall of about 60%. So what that means is, of all possible times that we could have shown these two translations, we only end up showing these two translations about 60% of the time. And that's because the two translations tend not to be the same. We also ran into scalability issues. So one was that building a classifier to detect this ambiguity on the source, it was data intensive. So we needed to collect lots of data where someone labeled these examples as saying, "This is ambiguous, this is not ambiguous, this is ambiguous, this is not ambiguous." So that's data intensive. And it's also tricky. So when you think about it, if you have a sentence like "my friend is a doctor," depending on the language that you want to translate into, the doctor can be ambiguous or not ambiguous. So if you're translating into Spanish, we know that Spanish has gender for doctor. So that's an issue there. But if you're translating into Tamil, for instance, there's no gender for doctor. So it's not ambiguous in that case, right? So it's a little bit of a tricky problem to actually build this classifier. The other thing was it increased our maintenance cost for maintaining the translation model. So what we did was we changed the underlying translation model to actually enable it to produce both the masculine and these feminine translations. So when we ask it to produce a masculine translation, it's able to do so. When we ask it to produce a feminine translation, it's able to do so. And then when we ask it to do translation in the default model, it's able to do so independent of the gender, right? So when you want to refresh this model, you actually have to refresh the gender component of the model. You have to refresh the default component of the model. So that makes it really hard to maintain and scale. So what we did recently was actually to think of this problem as a rewriting problem. So what I'm going to talk about next is rewriting-based generation of these gender-specific translations. So there's a blog post at the bottom if you want to know more. Here's our previous approach, right? So originally what we did was we were trying to detect these gender-neutral queries. We were trying to generate these gender-specific translations using the translation model. We would check for accuracy. But with the new approach, what we do is we first generate a default translation. And if the default translation is gendered, then we try to rewrite that default translation into an alternative so we can show multiple gender translation. And finally, we do the same step of checking for accuracy. So how do we build this sentence level rewriting system, right? So we need data. So we need data that goes from masculine to feminine and feminine to masculine sentences, right? So what we did, we started with some monolingual data. We programmatically generated these gendered alternatives. So you have this table here as an example. I spoke to her. We try to find all possible substitutions for her. Then it becomes I spoke to him, I spoke to his. These are the expansions, but we know from the context that the right one is I spoke to him, right? The same thing, the pen is his. It can expand to the pen is his or the pen is hers. What we know from this, for this particular sentence, the right one is the pen is hers. So how do we do the candidate selection? We basically break this tie by using an in-house language model. So a language model essentially assigns a probability to a piece of text, and we pick the piece of text that has the higher probability of occurring. So once we have the data, we have lots of masculine and feminine translation pairs. We merge both of these data sets. So by using a task tag, so we take the masculine to feminine data and we add a to feminine tag in front of it, and we take the feminine to masculine data and we add a to masculine tag in front of it, and we basically merge these two data sources and train a sequence to sequence model, right? So our sequence to sequence model is essentially a single layer transformer with one attention head. And we essentially train the simple single layer model because we believe that this rewriting problem is a much simpler problem compared to translation. So this single layer model is optimized for latency. For instance, when we serve these models on TPU for just doing the rewriting, the latency is about 5 milliseconds. We also initially we found some issues with the model being sensitive to casing and punctuation. So we introduced some noising in terms of adding casing and punctuation variants in the data for better robustness of the model. So finally, once we have a model, how do we evaluate it, right? So for doing the evaluation, we came up with a new metric to track our progress. We call it the bias reduction metric. So we define bias reduction as the relative reduction in bias between the current system and the new system. And we define bias as whenever there is an ambiguous source, if you're picking a gender when you are supposed to be showing multiple options, then that's defined as a biased event, right? So when someone says Ober Doctor, instead of showing 2 translations, you are showing 1 translation. So that's a biased event. So we basically define bias reduction as what percentage of queries is the current system biased for, what percentage of queries is the new system biased for, and how much did we reduce that bias by. So using our new rewriter approach, we actually get high quality gender specific translations. So for the previously launched Turkish to English system, we increased the bias reduction from 60%, as I was telling you, we had quality issues, to about 95%. So what this means is we reduce the bias of the existing system. We reduce 95% of that bias, and we're biased for only 5% queries. We also launched this feature for other gender neutral languages. So when you go from Hungarian to English, we have a bias reduction of about 94%. When you go from Finnish to English, we show you gender-specific translations, again, bias reduction of about 94%. Persian to English, we have a reduction of about 90%. And when we do decide to show these gender-specific translations, we have pretty high precision. So we're not wrong when we decide to show two translations. So 97% of the time, when we trigger these multiple translations, we're right. So when someone's saying it is an apple, we will not say he is an apple or she is an apple. That would be wrong, right? So we aim to have a pretty high precision there. So this is about what we've already done. What we're working on now is how do we also handle gender in documents, for instance, going beyond sentences, right? So here is the Wikipedia article for Marie Curie. I took the Spanish article and I translated it into English using Google Translate. And as you can see, about 16 of the 20 pronouns in the article are actually wrong. They're masculine. But we know that this article is about Marie Curie, right? So we're currently working on how can we best handle gender in documents and also other document level phenomena. That's all I had. So if you have any questions, you can reach me at melvinj@google.com. And I'm open to questions from Serena now.
Awesome. Thanks so much for that overview, Melvin. Yeah, really interesting to see what you did. And we're getting some questions in the chat, which is great. So first of all, I just want to check my understanding. So you had this first approach that you took near the end of 2018. So you started by someone would type their query into Google Translate, and first you would detect if this query is gender neutral. If it is, then you would generate these gender-specific translations. Then you would check for the accuracy of these translations. So I'm wondering, for this part of the work, and this question came up in the chat, where did you get your labels for this task from? Was it manual, or did you get the labels from somewhere?
Yeah, so actually, that's a good question. So getting labels is hard and expensive, right? So we were trying to be smart, and we were thinking about, is there an automatic way of getting these labels, right? And one thing that we realized pretty early on is going through English is always easy because English is very constrained in the number of words that it manifests gender in. So if you think about the English language, there are probably like 15 words that are gendered, like he, she, him, her, himself, herself, right? So what we did was we would go through our training data for Turkish to English, and we would look at the English side of it. And when we detected gender on the English, we knew that Turkish was completely gender neutral. So we know that the corresponding Turkish is gender neutral. So we used that kind of smearing the label from English over to the other language as a way of getting data in Turkish, for instance.
Okay, interesting. Yeah, so that is the first approach. And then just, to continue to check my understanding. So the second approach that you took later on, once you tried to expand this work to Spanish, is that right? So you started with someone would enter their query into Google Translate, and then you would generate whatever the default translation is. And if this translation is gendered, then you would rewrite it to an alternative. And you did this by using this sequence-to-sequence model you said that was trained using the data set that you created. Right. This data set is comprised of male or masculine and feminine translation pairs. Okay.
So actually for English to Spanish, we still use the previous approach of doing the translation system and generating the two translations. It's only for the 4 languages that I listed at the end.
Okay, got it.
Rewriting based approach.
Okay, yeah. Interesting.
Yeah.
Great. Yeah. So there are more questions coming in from the chat. So an interesting one asking about, and let's think about the first approach that you took. So if there's context, so let's say the sentence is Andrew works at that hospital, he is a doctor, then how would the translation change and how do you address this issue? Because Andrew, typically, you can say that it's a masculine name.
Right. Yeah, I think, so that's a good question. So what we do currently is we only have sentence level systems. So all of our input, even if you type in multiple sentences into Google Translate, we split them up into individual sentences and we translate them independently, right? So that's what I talked about at the end is we actually want to be able to model context. So when someone says, Andrew and they try to disambiguate who he is, we need to be able to learn from that. So currently we don't do that. And we're working on a solution where we actually can incorporate that context.
That's interesting. I think from an inclusion perspective, I actually like that you don't have that context right now, because you're saying it's sentence level, it's truly sentence level, and a woman could be named Andrew.
Yeah, it
no
could
problem with that. Yeah, exactly.
So assigning like genders to names is also tricky, right? Because there's some things that are highly likely to be one gender, and there are some things that are equally likely to be either gender. So you don't want to be making a call there as well.
Yeah. So another question coming in from the chat is, so at Google, are you considering taking similar approaches when translating other kinds of ambiguous sentences? So for example, translating sentences from languages that don't have these definite and indefinite articles, such as the/a, to languages that do?
Yeah, I think that is our goal, especially with the rewriting approach, right? We want to be able to modify the translation in many different ways. So gender is one aspect. You can think of formality as being another aspect, right? So certain languages, if you speak German, there is a definite, or if you speak French, there's the T and the we distinction. The T distinction being for less formal, and the we distinction being more formal, right? So when we generate a formal translation, we can kind of rewrite it, and we can show you both the formal and an informal translation now.
Interesting.
Yeah.
Okay. Yeah, that is very interesting. So yeah, I'd like to ask some more questions about the motivation behind the work and also the previous method you used. And then I have other questions specifically about this rewriting-based approach and also the data set itself. So I'm curious, in your experience, are there any other sources of bias due to society that we should be aware of, other than that comes up in the training data? I think when we had our coordination call, you said something about how human readers, when they're interacting with Google Translate, they themselves might be biased. And that's not from the training data, but that's just from, that's also from society. So could you expand on that a bit?
Yeah. So I think, most of these problems that we're seeing with these translation models have to do with the training data being biased, right? Because we basically mine data from the web and we train on data sources, and those data sources are biased. So we learn that bias. And there's been a lot of papers, as you guys might have discussed. We know that these machine learning models actually amplify existing bias. So if the existing bias in the data set was 1x, they make it 3x or 5x, right? The other thing that we know, for instance, is when we actually try to get evaluations of our translation, so we want to know how good is our system, we ask human raters to rate these translations. And we find, and other people have found that too, is that these raters tend to be biased too. And they might prefer masculine variants sometimes. They might prefer that the doctor is masculine, and they might rate the translation that picks the feminine gender for the doctor as a lower quality translation, right? So this is something that we were pretty aware of it, and we tried to make the instructions to the raters pretty clear in that they have to actually factor this in and rate it, and not take gender into account.
Interesting. Yeah. So I see that in your position at Google, you are in a position where you can make a bit of a difference. You can remind these users that a doctor can be a woman, doesn't just have to be a man. So that's really interesting. Yeah. So I'm also wondering, so this first approach, you mentioned that there was low recall when you expanded it to the Spanish-English translation pair.
Right.
So I'm wondering, did this show up when you were working with Turkish? And if not, I'm wondering, is it because Turkish is gender neutral, whereas Spanish is gendered? So it's sort of when you have this gendered to gendered translation, it like compounds the problem.
Yeah. I think you basically you arrived at the crux of the issue, right? Because Turkish is completely genderless. It does not manifest gender in any way. And we know that English, for instance, is gendered, but gendered in a very narrow way. It only has a few set of words that it genders itself in, right? So when you go from nothing to something really small, it's an easier problem. Whereas when we tried to do English to Spanish, we went from a little bit to a little bit more. So it's not black or white. It's pretty gray in English, right? So in English, something like doctor, when you go into Spanish, you might need to pick 2 words. But some other occupation, like, I don't know, lawyer, for instance, maybe in Spanish, there's only one word for lawyer, right? So these kinds of things, it actually complicated our launch a little bit, and it made it hard. But that's the thing, right? When you are actually trying to solve this kind of gender problem, you need a deep understanding of the language to be able to solve it in an effective way. You cannot take a hands-off data-only approach, because when you do that, you know the systems are going to be biased. So you have to be deliberate, and you have to understand what are the issues in the language, how does this language manifest gender, and how can we fix that?
So then, did you find yourself spending a lot of time studying Turkish and Spanish and these other languages in order to get this project done?
So yeah, that's a good question. So we're lucky at Google. So we actually interfaced with linguists for both Turkish and Spanish, and we work pretty closely with them. We worked with them initially to try to understand the issues in the language. We do multiple rounds of iteration with them. We tell them, this is what we're thinking. What do you think? We show them like initial model outputs so they can give feedback. So that actually helps. And I think that's important. And for all of the other languages that we've launched too, even if we didn't have any linguists at Google, we hired external, we interfaced with third-party linguists, and we spoke to them, we explained to them the problem, and we tried to get their feedback.
Okay, interesting. Yeah, that's a great way of finding resources for sure.
Yeah.
So we have a few more questions about gender neutral novelties. So Willie is saying, so I don't think there's anything wrong with gender neutral sentences or third person singular they. It is a feature of spoken and written language, and language learners, they will have to learn that along with everything else they're learning.
Yeah, so I think, so especially with the English they, we are working on how best to surface that. So we really want to show both the masculine, feminine, and the neutral option. And the thing that's tricky here is actually the user experience for the user, right? So even if you see these screenshots that I put, when you go from having a single translation to two translations, now you want to go from having two translations to three translations. So it tends to get a little bit crowded. Some initial experiments that we did, we were trying to find out the best user experience to surface this, right? Maybe the user experience is something like, we always show the neutral translation, and the user can choose whether they want to see the masculine or the feminine. Or we let Melvin pick that he wants masculine always, or we let someone else pick that they want feminine always, right? So we're experimenting with these different approaches of how to surface and give control to the users. But we hope to have the gender neutral variant.
Okay. Yeah, that's interesting. Thank you. And his main question really was just, why not gender neutral translations? I think you answered that. So from a UI perspective.
Yeah. No, I think so. I think there is we don't think that we should just show the gender neutral translation. We think we should show the masculine, the feminine, and the gender neutral translation.
Right.
So it makes the UX complicated.
Okay, interesting. So I'll ask one more question, sort of more at a high level before we dig more into the details. So one of the attendees, I should say, was asking, do you address biases in the form of sort of narration as well as in the context of thug speak or legalese or languages that have sort of gendered expressions such as in Japanese?
Not yet.
I guess, is it your plan to?
We're taking baby steps, and we're trying to, at every step, once we launch these features, we're trying to think of, okay, what's the next big bias issue with Google Translate that we can address, right? And we try to take a data-driven approach. We try to estimate how many users complain, how much feedback we get, what is the percentage of traffic in a language, how big is the problem.
Okay, interesting. Great, thanks. So getting more into this second approach that currently is in production for these four languages, or language pairs, I should say. So again, just to reiterate my understanding, so you get this default translation in whatever gendered form, and then if it's gendered, you rewrite it, and then you check for accuracy. So we have a question in the chat asking about, so this is applied mainly as a post-processing step, but this main algorithm, so the sequence-to-sequence model that was used in the original approach, how has that changed in the new approach?
So it's not. It's the same sequence to sequence model. Think of it as doing two sequence to sequence models in succession, right? It's just that the second model is lighter weight and much smaller compared to the first model. And the task for the second model is monolingual. It has to go from the same language into a different gender in the same language.
Okay, so to just clarify, so the more lightweight model, this is that single layer, one attention head transformer. Okay, and that's the rewriter.
Yeah.
Okay, so then that first sequence to sequence model that does the initial translation is the same?
It's much bigger. It's 6 layers.
Okay, sorry. It's the same as the previous approach, I mean?
Yeah, it's the same as the previous approach. Actually, it's so what we do is when we do build these translation models, we just train them on data, right?
Okay.
And in the first approach, what we did is we changed this translation model, and we actually gave the translation model some masculine data and feminine data, and we trained it to produce these variants. But with the rewriting approach, we don't change the underlying translation model. That way, we train it on all of the data. It can be biased. We try to pick the bias as a post-processing step.
Okay, got it. Great. So I'm also curious, when you were coming up with this solution, again, this is a bit more high level, but I'm curious about your thought process. So what other solutions did you consider other than post-processing?
So I think, well, definitely the one solution that we launched was do it in an end-to-end fashion, right? Which is to have one model. It can do both masculine and feminine and also the normal translation. And what we realized that is you have a single point of failure. It's harder to maintain. It's harder to build. It's harder to evaluate even because the same model has to do multiple different things. So you have to evaluate it on multiple different phenomena, right? So then we thought about how do we make it more modularized. That's when we came up with the post-processing approach. And it also seemed to us that doing the post-processing to go from one gender to the other is a much easier task than trying to actually do the translation in the gender that's specified. So that was also the motivation for us, is if we can reliably generate training data to do this kind of sequence to sequence, masculine to feminine or feminine to masculine or masculine to neutral or neutral to masculine, then we can do this as a post-processing step.
Okay, great. Thank you for that clarification. I'm also curious to learn more about this masculine to feminine translation paired data set that you had to create for this project. So could you speak again more to how you created this data set, and also is it released to the public?
Right. Yeah. So I think, as you guys know, like the one thing that we need and we spend a lot of time on is data collection, right, for machine learning models. So that's about 80% of all time, and then 20% of the time you're building models. So when we actually started thinking about this, we were trying to look for data sources that actually went from masculine to feminine. And when you think about it, there's very little data that has this kind of phenomenon. So we were trying to think hard, okay, can we look at Wikipedia edits and try to see if people change the gender? Or can we look at people who actually changed their gender during their lifetime? We can go look at their Wikipedia page and look at the edit before and after. And it's a very, very, very small percentage of data that you can find, right? Or for instance, maybe you can look at the King of England. When the King of England became the Queen of England, they had to change the gender everywhere. What can we find there like that, right? And there were no good data sources. So what we did end up doing is we actually tried to generate this data synthetically. So that's what I explained, is we start from monolingual data that's in one gender. And because in English, we know this mapping from pronouns, and it's not a one-to-one mapping, as I was saying, because something like him can go to his or her, depending on the context. So we try to generate all of these variants, and we try to break the tie with a language model.
Okay, interesting. And this tiebreaker, was this also a one-layer transformer, or what did you use for that?
Yeah, we used an existing legacy language model. It's an n-gram language model. If people are familiar with that, but it's not a neural model, but it works.
Okay, interesting. Yeah, and so is this data set available to the public?
Unfortunately, not. But I think I have an intern starting in a few weeks, and we basically want to replicate this exact work in a public setting and publish data and a paper about it. So hopefully stay tuned. We'll be able to release some aspect of this data. But
Awesome.
right now, it's not, yeah.
Yeah, I think, as I mentioned to you, our community loves NLP, so I think they'll definitely be on the lookout for that paper to come out. And so this data set that you created, so it's only in English, is that right?
Yeah, it's only in English, yeah.
Okay. And I'm also wondering, so how would this approach that you took, how would that change if you were to create this for, let's just say, Spanish as an example?
Exactly. Yeah. So that it's much more hard compared to English because, as people might know, Spanish manifests gender in many different words, in adjectives, in nouns, in verbs, right? So what we need is we either need to find a data source that goes from masculine Spanish to feminine Spanish, or we need a way of generating these alternatives in Spanish and breaking the tie again with the language model. And that's a little bit more intensive, but we hope to be able to, replace our existing English to Spanish model with a rewriting-based approach. So we are working on how can we best build this rewriter in Spanish, for instance.
Interesting. And so again, about this data set, I'm just very curious how you created this new data set for this project. So how long did it take to actually create this? So how much of the project did you spend working on just getting this data set done?
So I think, well, with this approach, especially for English, it was not too bad. I think I initially generated a version of this data, and I tried to build a proof of concept model. And then I tried to see, okay, is it going from masculine to feminine? Is it going from feminine to masculine? And then I tried to get it evaluated, try to compute some metrics on it. And then I realized, okay, I need much more data. So I went back and tried to generate significantly more amounts of data. And then I played around with a bunch of different data settings, as I was telling you, right? So initially, I was getting data from news websites. So I would basically take crawled news websites and take sentences from them and take these gendered sentences and try to generate variants of them. But the problem with news data is it's pretty well formed, and it always starts with the uppercase and it ends with punctuation. So when we initially gave the model text that did not have uppercase and punctuation, it started bombing, right? It produced nonsense. So then we had to introduce these casing and punctuation variants, introduce more noisy text to make it more robust.
That makes sense, yeah.
So it's a very iterative process. It's not like, okay, we're done with the data, now we have to train the model. You have to train the model, see how well it does, what are the problems, go fix the data again, retrain.
Yeah, I can imagine. And we have another question that's come in. Willie's asking a lot of really great questions in the chat. So Willie asks, so it sounds like this rewriting process is sort of going back to old-fashioned rule-based machine translation. And does that feel weird to you as a practitioner, given all of these advances in database translation?
So I think this is a good point. And this is also something that I tried to touch upon a little bit is we are building these deep learning based models that train on lots and lots of data, and then they try to produce very accurate translations. But then we realize that these systems are actually biased in certain ways, right? And for actually fixing the bias, we do have to go back and understand the different languages that we're working on. So we cannot take a very deep learning perspective where you're not caring about the data and you just like throw data at the model, right? So in that sense, we're thinking more about language specific things. So we're going back. But models themselves are still deep learned, they're still learning on lots of data, they're still parameterized, right? They're not rule-based. We don't have any rules that can make or break the system. We tried to, again, be robust. How can we generate lots of data and then build a model for it? So I think we're trying to find a middle ground here where we can try to address these kinds of biases while at the same time be data-driven and deep learning.
Yeah, makes sense. Thanks for that answer. So I want to ask something about this bias reduction metric. I was wondering, do you mind just going back to that slide in the presentation so the audience can take a look?
There we go.
Awesome. So I'm curious. So I assume that you plan to use this new bias reduction metric in future work you do on this any sentence level work and also document level work. And I'm wondering, can you see this metric be used in any other? Amir is just reminding you to click on present mode if you don't mind.
No.
Thanks. Yeah, just to make it a bit bigger. Awesome.
Yeah.
So yeah, I'm wondering, so this bias reduction metric, can you see this being used in other applications?
So I think one thing that I can see this being used is it actually forces us to measure bias in all of the languages that we have, right? So if we didn't have the metric, we wouldn't be measuring the bias. So what we're doing now is when we want to think about new languages that we want to launch, we go ahead and we measure the bias in the language. So for instance, when we started working on Persian, for instance, it was significantly biased. 90% of the time we were biased. We were picking the masculine gender, right? So in that sense, I think by having a metric and striving to improve it, we are holding ourselves accountable by measuring languages on this metric. But it's also useful in the document level context, the same metric, right? With the Wikipedia example, how much bias is there? 16 out of 20, that's the bias. How much do you reduce with your new system? So pretty intuitive and easy to understand.
That's great. And we have another question from Amir. Amir's asking, can you remind us how this metric is computed? And maybe could you just give a bit of detail, maybe walk through a sort of simple but concrete example if you could?
Right. I think, so basically, you can think of this in the precision recall setting, right?
Okay.
So the bias reduction metric is more like recall. So our problem is this, right? So you're given a sentence, you can do one of two things. You can translate it as a single sentence, or you can decide to show two translations, masculine and feminine translation. So when you do decide to translate it as a single sentence, when it's ambiguous, you're biased. When it's ambiguous and you decide to show two translations, you're not biased, right? So what we do is we take our existing system. Our existing system did not support any way of showing two translations, right? So every time there was an ambiguous sentence, if it picked a gender, it was biased. So if you didn't have a gender-specific system, you can go ahead and take a list of test set, and then you can see how many times it picked a gender where it shouldn't, and that's the percentage of bias, right? This is for the base system. And for the new system, every time there's an ambiguity, you basically have to see if you're showing two options to resolve that ambiguity and to handle that bias. So if you did do that, that's a positive. And if you didn't do that, that's a negative. So we then measure how much bias does the new system have. And that's basically how we measure the reduction in bias.
Okay, interesting. So
so I think it's in some languages, it gets a little bit more complicated. Like for Spanish, you can actually express something as completely neutral in Spanish instead of talking about the pronoun. So when you say, he went to the market in English, in Spanish, you can say he went to the market or she went to the market, or you can actually say went to the market. You drop the pronoun and that's completely okay, right? So when you have something like this, when a system says went to the market, it's actually not biased, right? So that then we actually factor that into account. So when you're picking a neutral variant, when you're saying they are a doctor, there's no bias there. There's only a bias when you pick a gender when you shouldn't.
Okay. So then bias percentages then out of all these translations that were ambiguous, how many were gendered when translated when they shouldn't have been?
Exactly. That's bias percentage.
Okay.
And then bias percentage in the new system is the same thing. And then the reduction in that percentage is giving you the improvement that that we told you. So when we say we reduced 95% of the bias, so if the previous system was biased 50% of the time, we reduce 95% of that 50%.
Okay, interesting. Yeah, and you mentioned that it is similar to recall, and I would assume that when you were looking around for a metric to use, you didn't find anything that addressed bias in different systems. And I'm just wondering if you could speak to, is there any research out there that you've read where there is some sort of metric that is, in a sense, measuring bias?
I mean, I think, definitely recall didn't work for us, right? Because the definition needs to be changed a little bit for our use case, and that's what we ended up doing. And we couldn't find other metrics. We found like similar metrics that were looking for accuracy of producing the right gender, But I think what we came up with is very similar to recall, but just changed to suit exactly this problem, right? And because I don't think other people have the same problem, especially I think we're the first translation engine that has this feature, right? So we couldn't find literature that tried to devise a metric for this problem.
Interesting. Yeah. I mean, that makes sense. So I'm also curious about when you do go to the document level work. So you started at the sort of single word level, and then you moved to sentence level. Then you realized there were some sort of hiccups in this approach once you expanded to another language. So are you able to sort of look ahead and see how the architecture and the solution might change when you do go to document level?
Yeah, I think it's going to be radically different, right? Because you're not operating at the sentence level anymore. You need a model that's able to understand long-range dependencies in the document, right? So, for instance, in this document, you need to be able to have access to the entire document and understand that, okay, this is about this person is feminine, and this sentence is actually talking about that person, whereas this other sentence is talking about the person's husband, right? So I think the models need to have some sort of document level understanding.
Yeah, and as an intermediate step, would you maybe consider paragraph level first and then document level?
Yeah, that's a good point. We have considered doing something like that where we take chunks, try to translate paragraphs, as you were saying. But even at the document level, you can think of chunking up the document into paragraphs, and you try to, basically you have to decide what amount of context do you want. Is it everything in the document, or is it like few sentences before and few sentences after, or is it 10 sentences before and 10 sentences after? Yeah.
Interesting. Yeah, and looking forward to when you expand this work. So you've used transformers for this, and of course there's a lot of very interesting work in NLP coming out all the time. It's almost impossible to keep up. Do you have your eye on a particular model or architecture you'd like to try out?
So I think, so most of our models, as I was telling you, right, we operate in this kind of sequence to sequence world where we try to go from one sequence to another sequence. But especially with these document level understanding scenarios, we're trying to see if there are interesting ways we can leverage BERT, for instance. So we run BERT on the document to try to get some understanding or embedding of the document. And then we figure out a way of feeding this embedding into our translation system.
Interesting. What about, would you try anything beyond BERT?
Well, whatever the bigger variants of BERT.
Okay. Okay, cool. Yeah, that's great. So I have not prepared any other questions. I'm going to give the audience a few more minutes to see if they have any other questions. Melvin, is there anything else you'd like to highlight before Oh, there's another question. That's great.
Okay.
So, yes, would you be able to remind us about the scalability part? So from my understanding, the previous approach was not scalable in that it was data intensive because you would have to create a particular or a language model for every source language. Could you also check my understanding on that first of all and just remind me, why it wasn't scalable in the first place?
Yeah, so I think essentially you can think of it as, okay, there's a Turkish to English translation model. We've now changed that model to support Turkish to English translation and also Turkish to English gender translation.
Right.
That means that it can now produce masculine and feminine, right? So now, if someone else actually comes up with better data and a different technique that improves the quality of the Turkish to English model, they have to actually update both the underlying model and the gender component of it. So that makes it harder because they might have like better quality underlying, but then that might bring down the gender translation quality, right? Both of those factors became tied together, and we wanted to decouple them. So that's why that was the issue. And the other issue is also just it's harder to get training data for building a translation model because you need data both in English to Spanish or Turkish to English. Whereas if you're operating in the monolingual setting, it's easier to get data in the monolingual setting.
That makes sense. Yeah. So to just check my understanding. So the scalability is sort of in terms of training and being able to apply this method to many more languages rather than add inference time and it being very fast when you actually query it.
Right.
Okay, got it. Great. So then, I don't think there are any other questions, so we can wrap up. So I will just highlight some key takeaways from the session. So key takeaways would be that machine learning applications, they are biased due to training data. And this is because of the systemic bias that is in society, unfortunately. Now we can work to fix these societal biases, and this is definitely important to do. But at the same time, machine learning practitioners, we shouldn't be waiting for society to fix itself. We should do what we can to mitigate these biases so that we can harm the least amount of people as possible. And ideally, we could create applications that are truly inclusive for everybody. So Melvin, you and your team, you've done a really great job. As I said, you're in this position of power and you actually could make a difference with this. And you're working with this bias training data that you're given, and you're translating this into a product that has less bias than before, and about 95% less or so across these 4 translation pairs, as you mentioned, according to this new metric that you developed, which I think is very cool. And then turning to the development of the model. So developing a model as before that first detects gendered queries, then translates them into other gendered versions. It's not very scalable. And that reason, or one of the reasons being that building a classifier that detects gender neutrality in every source language, that's data intensive. So this post-editing approach is so you're using the sentence level rewriter. It's scalable and it's better, especially when translating from gender neutral languages into English, since then you don't need this gender neutrality detector. So yeah, Melvin, you said that you and your team at Google Research, you plan to extend this work out to different languages and also from the sentence level to the document level as well. So everybody at ACE, definitely be on the lookout for Melvin's research, be on the lookout for this data set, this masculine to feminine translation pair data set that Melvin is hopefully going to be releasing soon so we can all play around with it. And yeah, I just want to thank you so much, Melvin, for coming out to this session. It's our first algorithmic inclusion event, and I think it went really well. And yeah, I appreciate you presenting your work and also choosing a project that actually aims to mitigate societal biases rather than make them worse. And even better, it's in a tool that everybody uses every day. So I think that's great. And to the audience, thanks so much for joining us. And I definitely would love all of your feedback on how this new format went. Personally, I think it was great. I had a lot of fun chatting with Melvin and really felt a lot more conversational. So I hope you all got a lot out of it. So Melvin, if you'd like to say anything else before we end, please go ahead.
No, I think just thank you for inviting me. I'm happy that you guys are excited and you have this series on bias. I think it's important that everyone tries to fix the biases in their models that they're building, and hopefully we can fix more biases in Google Translate.
Awesome. Thanks so much. Well, have a great night, everybody.
Bye.
Bye.